Hello, my favorite kiddos. I hope you really enjoyed your 3-day weekend. I'm sure it's much needed just after hopefully not too stressful of a first week of this e-learning that we're doing. Just remember, it's an adjustment for all of us, you kids at home, whatever you guys have going on. Just remember, teachers are going to be willing to work with you. So just communicate with each of your teachers, not just me, but everybody else. Just keep them in the loop if you're struggling. We're here to help you. So speaking of helping you, before I talk about the lesson we're actually going to be doing today, I kind of wanted to mention something from last week. So I was going through and looking at your lesson 19 and 20 exit tickets from teams, and I wanted to make a couple statements. So if I look at this, first of all, there were some kids that made this mistake. So it shows you here that they're working together at this piano factory. They both were hired on January 3rd, but Jenna was hired back in 2005 and Allie was hired in 2009. Okay, so Allie got hired later in the years, more recent than Jenna. So if I was to do this, okay, first of all, I need to understand if it is 2010, how many years is Jenna worked and Allie worked? So if Allie worked in started working in 2009, I could just take 2010, erase that. That is not 2010. Okay, I could just take 2010 and then subtract 2009. And it would be 1 year. She's only worked 1 year. So then I would just put a 1 for Allie. Okay, if I go back to Jenna started working in 2005. So if I take 2010 minus the 2005 start date, you would get 5 years. So Jenna's worked 5 years, okay, while Allie's only worked 1. So if I fast forward 1 year forward, okay, now Allie's worked 2, Jenna's worked 6. In 2012, Allie's worked 3, Jenna's worked 7. 2013, Allie 4, Jenna 8, 5, and 9. So that table was pretty easy for you to see, but if you look at these next questions, this is what I wanted to mention for a quick second. It says, if both workers continued at the piano factory when Allie has A years, so Allie has A years, how many years of experience will Jenna have on the job? Okay. Remember, you can use these tools. If you have a stylist, you can use the same tools that I'm using right now. So if I look at this, I want to figure out if Allie has A years. And I want to figure out how much Jenna has and write an expression for that. You're thinking about how you're going from Allie to Jenna. So think about how you go from Allie to Jenna. If you do that for this, it should all be the same thing. Okay? If you think about, so I start with Allie. How much am I adding to Allie to get to Jenna? You're adding 4 years of experience. So I saw some people give me that, but I saw a lot of just random things written down, but that's going to be super important to understand. Okay? If you look at question C, it says if both workers continue working at the piano factory when Allie has 20 years of experience on the job, how many years of experience will Jenna have? So I'm using this equation right there to figure this out. So I have Allie plus 4 years. Now, a lot of you people can understand that you're adding 20 to 4, but you're plugging in this number right here for A. So it's like 20 plus 4 would be 24 years. Bam. So you want to understand. You want to find the equation because it'll really, really help you, especially when we get into today. Okay, if I look at the next thing. So Anna charges $8.50 per hour to babysit. Complete the table below. So if she works 1 hour, she makes $8.50. If she works 2 hours, what I'm doing is I'm just taking $8.50 and multiplying it by 2 now. So she makes $17 and so on. And then I add another 850 or I multiply. So in this case, going from this side to this side, I'm taking it and multiplying by $8.50. So what you should have done, okay, in A, it says write the expression for the earnings for H hours. You should have taken the $8.50 and multiplied it by hours, whatever it is, to be able to figure out how much she makes. Some of you put the craziest things in, but if you just slow down and you think about what you're adding to this glorious table, it will help you figure out what the equation will be in that problem. Okay, so make sure you understand that. So if you look here now it's the opposite. So I'm going to skip this because I think we understand if we plug it in here, just like we did here, we'll get our magic number. Okay, down here you need to understand, it says how long will it take for Anna to earn $51? So I'm not plugging anything in here, okay? But what you need to understand is that you're doing the opposite. So instead of going from hours to dollars, now you're working backwards. I'm going from dollars to hours. So instead of multiplying by $8.50, I'm just going to divide by $8.50. So then what you should have done, okay, what we should have done is if we scroll down, you should have taken the $51 and divided by the $8.50 per hour, and then that would have given you the magic number for how many hours she worked. So you got to remember, if you go from hours to dollars, you're multiplying by $8.50. But if you go from dollars to hours backwards, you got to do the inverse, which is dividing by $8.50. So I just wanted to touch on that, okay, so that way you guys understand it. Now what we're going to do is we're going to look into what we're doing today. So same kind of concept, except now what you're going to be doing is you're going to be taking it and not just multiplying or not just adding, okay, you're actually going to be doing both. So it's 2 steps, so you have to think about each problem very carefully. So you're going to be going through this whole entire packet, okay? I'm going to do some of it with you. You're going to answer the questions, and then if you look, I will post the answers through the packet for today, and then tomorrow what you're doing is, okay, you're going to be checking everything, and you can go in and check your problem set. So if I look at this, it's a modeling exercise. So the Italian Villa restaurant has square tables that servers can push together to accommodate the customers. But only one chair can fit along the side of a table, which means only one chair can fit here, a chair can fit here, a chair can fit here, and a chair can fit here. So it wants to make a model to figure out how many seats we can fit at each table size. So if I only have one table, how many seats could I sit? Well, if you look at this table right here, how many seats are there? Right, exactly, only 4 seats. So one table is 4 seats. Now let's look at the 2 tables. So if I push 2 of them together, and I can only sit 1 chair at each side, which here's 1, 2, 3, 4, 5, 6. So 2 tables, I can see 6 chairs. Okay, let's think about 3 tables. It's a little skinnier. So 1, 2, 3. Right, exactly, 8 chairs. So we're going to keep doing this, and you can add those into the next, but you're going to start to see a pattern. If I add another table, don't judge my drawings. So I'm going to add the chairs. So 1 here, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 4 tables is 10. Do you start to see a pattern? As I work down my way through this whole entire table right here, do you start to see a pattern? Some of you might say, yeah, I just add 2. But it's not just adding 2. Okay, it's 2 steps. It's not just 2. It's 2 steps. So what you're doing here is you're multiplying by 2 for tables, and then you're adding 2 chairs for the ends. Because each table can have 2 chairs, and then you have your 2 end chairs, so you would add the 2 end chairs after you do that. So the problem would look like this. So chairs equals 2 times tables plus 2. And you want to group that together and make it look something like that. So then we could use that formula right there to figure out the whole entire table. So 5 tables. So 5 times 2 is 10 chairs. And then I have my 2 end chairs over here. So I have 12 chairs. So now we get into like a really, really, really big like Italian family at Italian restaurant. So 50 tables. That's huge. Okay. So I would take the 2 times 50. Hopefully you understand that is 100. And then I'm adding my 2 chairs. So I would have 102 chairs. So just go plug in 200. So 2 times 200 is 400. And then add 2. And you get 402 chairs, right? Extremely big family. So here's what you guys also got confused about. When I put a letter here, that means how do I go from tables to get to chairs? So how do I go from tables to get to chairs? And we just figured it out right here. See, this is what we can use for the whole entire table. So it would be 2 times t plus the 2 chairs on the end. So there's a lot of things we could do. Okay, if you think of another way, I want you to write it here. If you can't think of another way, it's okay, just leave it blank. But the reason why we wanted to come up with this is because if you see, it says it's super impractical to make a model for pushing 50 tables together, right? I didn't even want to do 4, but I did it to show you. So putting 50 tables, 50 squares together, that's a ridiculous model. So that's why it's super helpful to come back to our equation that we came up with to be able to figure out the table. So if it says if we have a rectangle that is that long, how many chairs would fit on the long sides of the table? So the long sides, if I have that, okay, just the long sides, there would be 100 chairs. Because 50 on each side, 1 person on each side of the table, and 50 tables, I would have 100 people. But then you have to think about how many people can fit on the end, right? Remember, there's 1 person on each end, so there would be 2 chairs on the ends, which comes up to 102 chairs. Exactly what we just said right here in the table. Okay, we worked a little bit ahead. So obviously, we're not going to do this. We already put it in the table. We actually already did this too. It says if we let T represent the number of square tables that make one long rectangle table, what is the expression for the number of chairs that fit around it? So remember, we take the tables, so we multiply tables times 2, and then we add my 2 end chairs. So your equation would be 2t plus 2 equals chairs. So here's another example, right? We always talk about like, why in the world do I need to know this? How can I add it into math? Well, how many people order pizza, right? I probably do it once, hopefully not even twice a week. So if I look at this, there's a cost for pizza, but then there's always that stupid delivery charge. So Pizza Queen has a special offer on lunch pizzas, so they're only $4 each. But then you have a $2 delivery charge regardless of how many pizzas you order. So I want to determine the cost for the various number of pizzas and then determine the equation to figure it out for all types of orders if I'm ordering a certain number of pizzas. So if I do this, okay, let's look at these first little steps. So what math operations do you think we need to do? Well, they're $4 each, and it's a $2 delivery charge no matter how many pizzas I order. So My guess is I'm going to multiply by 4 for the pizzas, and then I'm going to have to add the $2 at the very end. So if I order one pizza, the pizza costs $4, but then I have my $2 delivery charge, and it costs $6 to order one pizza and get it delivered. Okay, now if I have 2 pizzas, well, 2 times 4 is 8, plus my $2 delivery charge is $10. 3 pizzas, 3 times 4 is 12, plus 2 is $14. 4 pizzas, 4 times 4 is 16, plus 2. No, it's not 4 times 4. Yeah, 16 plus 2 is 18. Okay, so it'd be $18 to order 4 pizzas. But what about 10 pizzas? Does the delivery charge change? No, right? It's just still $2. So I'm going to take my $4 times my 10 pizzas to get $40, plus my $2 delivery charge becomes $42. It's a pretty good deal. Better than your Fox's Pizza down the street. So, 50 pizzas, right? Something like what we would do at the end of the year if we have state testing, okay, for our big old pizza party. So, 50 pizzas times the $4. So, 50 pizzas times $4 is $200, plus my delivery charge. So, it's $202. So, only $202 for 50 pizzas. It's not too bad. Okay, but this is where we get confused. Okay, this is where you send me a remind message or a Teams message. Hey, Mr. Medford, what in the world does that P stand for? Well, look, the P stands for pizzas. So we just did it in our head. You just did it for the whole entire table. How do I go from pizzas, that magic pizza, to figure out my cost? So remember, I multiplied by 4, and then I added $2. So it'd be 4 times pizza plus my $2. Okay? Because here, if I know this, right here, I'm going to be able to do any number of pizzas for any number of order for any person. So let's look down here at some questions. What mathematical operations did you need to perform the final cost? Well, we had to multiply, right? Still have my handy dandy highlighter on. So we had to multiply first, but we also had to add, right? Remember, beginning of the lesson told you you're going to have to do more than one thing, okay? And it's multiplying and adding in this case. So suppose our principal wanted to buy a pizza for everyone in our class. Determine how much would this cost? Well, obviously it depends on what class you're in. So let's just go first period. There's 18 kids. So my first period is 18 kids. So I'm going to order 18 pizzas. I want to know how much it costs. So I can use this equation that we found. 4 times the 18 for P, for pizzas. And then I'm going to add my $2 delivery charge. Right? This is why we learn order of operations. You have to multiply first before you add. So if I take 4 times 18, okay, scratch math, $72, but then I need to add my $2 delivery charge for $74. Okay, that's how much the principal would have to pay. So only $74 for my first period to get a whole pizza each, right? If they eat a whole pizza each, I think they have an issue. So hopefully we have leftovers for at least second period. Don't know about the rest. So we looked at it one way. Now we're going to look at B. It's going to go backwards. It says if the booster club had $400 to spend on pizza, what is the greatest number of pizzas they could order? Okay. So now we're working backwards. We know the total cost right here. Now I want to figure out how many pizzas that is. So we're going to work backwards exactly like we did in the top problem. So think about it. Inverse. Okay. Inverse, opposite, whatever you want to call it. Instead of multiplying now, we're going to divide. And instead of adding, we're still adding. Okay? Or should we subtract? Well, let's save that to the end to see. Okay? So I have $400. It's $4 a pizza. So I'm going to divide by 4. So what's 400 divided by 4? Right, exactly. 100 pizzas. But you can't forget about the delivery charge because it's 100 pizzas. But if I subtract $2 from it, I have $398. Okay? So now I don't have enough for 100 pizzas. But I do have enough for 99 pizzas. Because 99 times 4. Scratch math. $396. Okay, but then my delivery charge, I have to add the $2 to it, so it becomes $398. And then we'll let the booster club have $2 extra. Okay, so we worked backwards there, right? You see how we did that? We had to problem solve just a little bit and work backwards. So let's see if you can do it. Right here, it changes just a little bit with the pizza cost and the $3 delivery charge now. Think about exactly what we did in example 1. See if you can do it here. Okay, and then if you look, here are the problems that you're going to have to do. But please, think about it, think about it, think about it. Walk you through it. I'll add some notes. Okay, let me know if you have any questions. Hopefully this helps you. Don't forget, you can now chat with teachers on Teams, individual chats. Okay, so if you don't have her mind, stop emailing me. Send me a message on chat. Don't forget, you're supposed to send me your problem set, a picture of it to prove to me that you had it done. If you have questions, I'm available. Don't message me at 7 p.m. at night asking me questions, though, right? That's family time. But hopefully you have a great Tuesday. Enjoy the rest of your day. Go play outside. See ya, Mr. Mefford.